Hello and welcome. My name is Lisa Marginelli. I'm with Issues in Science and Technology. We're a quarterly journal that's a partnership between the National Academies of Sciences, Engineering, and Medicine and Arizona State University. Today's discussion is being co-hosted by Issues along with ASU's CSPO, which is the Consortium for Science, Policy, and Outcomes. We're delighted that you're here. This is a stunningly global conversation. We have people from Brazil, from Australia, from India and Pakistan, from far off San Diego. I think that is a credit to the interest that is sparked by the topic of today's discussion, which is, does engineering education need a revolution? Before I introduce the moderator, I want to say a little bit about our general goal for these events. In part, we want to bring really interesting people with expertise in specialized topics to reflect on the way science, technology, policy, and society interact in the real world. And here, of course, we're talking about this very important topic of engineering education, which has a long history and plays a great role in the future of the world in how we all navigate the connection between society and technology. So such discussion requires not only experts, but lots of other people, society. And in other words, everyone here on Zoom is an important part of this conversation. So about half of today's event will be a moderated discussion between the panelists, and the other half will be the panel engaging with the questions that you ask and the issues that you feel are important and interesting. So to enter your questions, please use the Q&A function. To chat amongst yourselves, you can use the chat function, but for the Q&A, please use that to communicate with the moderator, and we will work to get those questions through to the moderator. So let's get started. Our moderator today is Jessica Marshall. She is a science news editor with Chemical and Engineering News. She is also a chemical engineer, and after leaving the bench for journalism, she worked as a freelance science journalist for a decade, covering all sorts of topics, and then she returned to the molecular beat when she joined C&EN as an editor in 2015. She lives in Seattle. Welcome, Jessica.
Thank you so much, Lisa. I'm really looking forward to today's conversation. My own engineering education had its ups and downs, so I'm really eager to hear from everybody's, to hear from our panelists and hear all their thoughts. I wonder if maybe rather than sort of turning on cameras one at a time, if you guys all want to turn on your cameras now, I will introduce all of the panelists briefly so we can jump right into our conversation. Our first panelist is Dr. Gilda Barabino, the president of Olin College of Engineering and professor of biomedical and chemical engineering. President Barabino is also the president-elect of the American Association for the Advancement of Sciences. Thanks for being here.
Thank you.
Our second panelist is Dr. SHERYL SORBY. Dr. Sorby is past president of the American Society for Engineering Education and professor in the Department of Engineering Education at the University of Cincinnati. She is also professor emerita of mechanical engineering and engineering mechanics at Michigan Tech. Welcome. Our final panelist is Dr. Norman Fortenberry. Dr. Fortenberry is the executive director of the American Society for Engineering Education. Welcome, Dr. Fortenberry. Dr. Sorby and Dr. Fortenberry are co-authors, along with Gary Bertolini, of an essay titled Stuck in 1955, Engineering Education Needs a Revolution, which was published in Issues in Science and Technology. This essay argues that engineering training has not changed substantially since the release of a report on engineering education in 1955. The essay argues that this lack of change has perpetuated racial and social disparities, elitism in academia, and locking students out of engineering pathways as early as elementary school. So please start us off, Dr. Sorby and Dr. Fortenberry. Tell us why engineering education needs a revolution.
SHERYL, you're muted.
I think there's many reasons why engineering education needs a change. If you think about the way we all learned engineering times have changed so vastly that it's remarkable in many ways. We can look things up on our phone that it might have taken us a week to find in the library when we were undergraduates or graduate students. So why are we still teaching the same way that I learned, right? And others have learned? We haven't changed. Times have changed. The population has changed. And there's so many technological advances. It seems to me like it's time for a change. And as we pointed out in the essay, our system has been really one of keeping people out, and we want to make sure that we have all the creative voices sitting around the table when we're coming up with design solutions, not just the same old people who have been sitting there in the past. And so we need to hear different perspectives, but we cannot hear from those people if we always intentionally keep them out through our practices in terms of curriculum and admissions and progression and all of that.
Dr. Fortenberry?
Just pick up on what Dr. Sorby was speaking to. I think there's a point to be made with regard to student interest in real world relevance. We're beginning to see little pieces of that in some programs. And students are very concerned that in an increasingly technological society that engineering demonstrates its relevance to social justice and equity. There are concerns about how technology will be used or misused with regard to algorithms. We're seeing that or ill-used. That's the other example, bathroom faucets that don't work for people with dark skin. Any number of questions about how technology is used or misused and how it is applied or misapplied are things that we need to begin to be much more explicit about in the curriculum. And I think, if you just pick up on that thread, there are issues then in terms of racial or social inequity that have resulted in unequal access to collegiate learning resources. If I dig back in my mind in terms of which students had access to course Bibles, for example, which really big aid in studying for a test, or even access to an engineering pathway. So in terms of who has access to calculus in high school, all of those issues sort of play into the assumptions that faculty make about what resources are available to students, what students are coming in the door with, and therefore, although there are some spotlights of change, in general, I'd say with glittering generalities, there's a need for much greater change across the board.
Yeah, there's so much to dig into there. Professor Barabino, you are the president of an engineering college that is pioneering new ways of thinking about engineering education, maybe getting at some of these issues that we just heard about. Can you tell us a little bit about some of the things that you and your institution are doing differently?
Sure, and thank you for the opportunity to do that. So Olin College has been pushing back on this current model that we've all been participating in for the reasons that Dr. Fortenberry and Dr. Sorby outlined since its inception in 1997. And the idea was to really just start with a fresh slate. What should we be doing? How should we be educating? Making reference to and understanding that the world has changed and how do students learn? So the way it's been approached has from the very beginning, it's okay, let's do project-based learning based on real world problems. Let's have team projects. Let's work across disciplines. And as we are formulated, we are interdisciplinary. We do not have departments. The projects are very much driven by real world problems, but also this idea that you are centering the user. Who is it we are designing for? So one of our signature approaches is called user-oriented collaborative design. So this constant idea of thinking of who you're designing for and involving them in the design process. Another part of it is, if you think about how we've all been educated, especially for engineering, is this idea that you cannot even touch design or the kinds of things that you apply until you've had some theory and background, until you've had a certain amount of foundational chemistry, physics, and math. And what we do is we have students to start designing from day one, entering students, and they're designing throughout the entire curriculum. Another part that's really important is to involve the students in the design of the curriculum. So the students are playing a very integral part in their own learning and how we design for that learning. Another piece that was very interesting at the inception was gender parity. So all of the classes, starting with the beginning class, had gender parity from the very beginning. And I would say what's really interesting in terms of moving forward, what we're thinking about now, is how do you infuse on that equity, access, and affordability? So we are designing for and educating for humanity. We're looking towards social justice. And so this idea of like, how do you do that collaboratively and real world problems, team-based, project-based, that we believe is the way for the future.
That sounds very different from a traditional engineering education. I wonder, what are the barriers to these kinds of approaches taking hold more broadly?
I think there's several barriers. I think one of the large barriers is the current faculty reward structure and some of the systems we have in place on our campuses. Dr. Barabino was talking about having gender equity as one of the founding principles of their programs. The rest of the engineering programs around the country couldn't do that, probably, right? We wouldn't be allowed to do that even if we could somehow miraculously have equal numbers of men and women applying to our programs. But I think the faculty reward structure, where really faculty are rewarded for their research and not necessarily for their teaching, not necessarily for their mentoring, not necessarily for their ability to inspire students, that is, I think, one of the big hindrances. I think another is just that I think engineers by nature are conservative. And so we don't want to change. We say, well, that was good enough for me. It should be good enough for everybody, right? And so getting over some of that mindset that we can't possibly change this, or ABET won't let us change things. All those kinds of things are a hindrance, I think.
I would add to that you have to recall that the first engineering program in the United States was started at the U.S. Military Academy at West Point. And so a lot of that perception of a military culture was carried over into engineering culture. But there's something that's very important to remember. Within the military, when people go through boot camp, they break you down as individuals so they can build you back as a team. That is an explicit part of what boot camp is all about. And in engineering, we're very good at breaking down students, but the effort to build them back as a team is something that's left to the students and their peers on their own, by and large. So, the few, the proud, the engineers is sort of an attitude that you will see on any number of campuses. We're the engineers, we're the ones who study all night. But the ability to bring them together consciously and how to have them move forward, that's why we lose so many engineering students who are incredibly capable, but say, this is not an environment that I want to be in. And given the demographics that this country is looking at, we can no longer afford to be a filter. We need to find ways to be much more inclusive.
Well, just to pick up on that thought, it shows that as a barrier, it's our culture, it's our systems, it's our environments. And when we think about creating change, we often think about, well, let's fix those broken individuals so that they'll fit into the broken system, instead of thinking like, maybe we need to adjust our system. Maybe we need to change our cultures and environments so that they are more supportive and welcoming for people from all different backgrounds. And so this idea of systemic change is starting to catch on somewhat, but it's a real struggle because it's like what Dr. Sorby just said, like nobody wants to change. Like there's this real resistance to change at all. And our structures, our systems, our reward systems are not set up for the new ways of thinking and doing. But if we start to address things more systemically and not just look at how do we address individuals and individual interventions, I think we can actually break down some of the barriers. Having conversations like we're doing now and pushing that out, because we need to challenge the assumptions. We need to challenge the kinds of things that are just mindsets that are taken as givens and say, no, it doesn't have to be that way.
Yeah. So much of this resonate in my, things that really resonate with me are this idea that it was sort of like breaking you down, this hazing, which is something that was mentioned in your essay, like definitely felt like if you could hack it through the first 2 years or whatever, that was a huge part of the culture. Another thing that I thought was interesting that has been mentioned a little bit here is just this idea of, I felt as an engineering student, I didn't at that point, and I think things may be changing, see engineering careers ahead of me that I felt let me address like humanitarian problems or things that really made the world a better place. And I know that's things that you guys have touched on. Does anyone want to say a little bit more about that, about changing the sort of problems that engineers are focused on as part of this?
Yeah. Well, I don't mind starting on that. Like, I think if we think about a social justice mission and thinking about making society a better place, a more humanistic approach, because part of when we are in these technical fields, it's often when you talk about the human side, it's like, well, what does that have to do with engineering? Or what does that have to do with science? Well, we are people serving people. So you can't leave the humanistic side out of it. Also, science engineering is social. It's a social construct, and you cannot operate without thinking about that. I also think it's like really important to think about those we are trying to attract, especially when we're trying to reach out to those who are from racially minoritized groups or women. You're talking about people who often really want to give back. They want to make it better for other women, for other people from racially minoritized groups. And Ebony McGee and some of her colleagues have written about this. They talk about the equity ethic. So this real strong desire to give back. And there's a disconnect because most don't see our field as a way to do that. So if we can change that narrative and people can make the connection to engineering as a path to social justice, as a path to making it better for other people, I think will make a huge difference.
I think when I went through school, when we were talking about design or optimizing things, all we ever talked about was cost. We never talked about what's the impact on the environment from whatever it is we're proposing? What's the impact on the neighborhood where we're building this landfill or something like that? And so echoing what Dr. Barabino was just saying, I mean, we need to have our design projects and design problems and challenges that people are interested in solving, because you know what? Not everybody is inspired to make something that's less expensive. And the example I always give is not everybody is inspired to build a faster race car, right? People want to be able to impact society around them. Unfortunately, all of us sitting around this table, we all went through the same system. So, we have to shift our mindsets too. It's not just those people, because I still have problems trying to shift the way I'm thinking about things, even though I'm consciously trying to do it. But it will be an effort, but I think we have to do it or we're not going to survive, because if we can't get people to come into our programs, we're going to cease to exist. And if we can't make it more interesting, more welcoming, more equitable, more all of that, we're not going to have any engineering programs in the future.
There's questions coming in, and I'm eager to start to ask some of those. But just before we do, Dr. Fortenberry, I don't know if you wanted to leave an answer to this one, but can you give any other sort of specific vision for how you see the engineering program being different, especially at a place maybe not like Olin College, which has just built something new from the ground up, but what are some of the pieces, the things that people could do in their departments to move down this path?
So let me give you an example from a different type of institution. Purdue University is very large in contrast to Olin's size. Purdue has a program called EPICS, Engineering Projects and Community Service. It is a 4-credit course. It spans the undergraduate years from first year through fourth year. That EPICS explicitly works in collaboration with local nonprofits, community-based nonprofits, to do engineering projects for their clientele. That's one. Well, so it's important that it is 4 credit. It's important that it is all 4 years so that you've got peer mentoring of seniors to juniors, juniors to sophomores, sophomores to freshmen. And it's important that it works in the local community. But it's also important that EPICS, to the best of my understanding, has a continuing responsibility to the nonprofits with which it has worked in the past. So, which is important to me in terms of how an engineer needs to think about their job. So 3 years from now, whatever was done with nonprofit A is now obsolete because the technology has moved on. The current generation of students is responsible for what that previous generation of students did. And I think that that instantiation of responsibility for what has been done by those technical professionals before you emphasizes thinking through what you've done, but also documenting what you've done so that those who come behind you can pick it up and understand it to either fix it or improve upon it is crucial. So those 4 elements within EPICS, a very concrete example that exists that is now actually a international model. EPICS type programs have been picked up around the world. So one example.
Great. Sorry, did you want to say something?
Yeah, I was just going to say that another, I think EPICS is great, but I think another way that we could change our programs are, right now everything's lockstep. You have to come in, you're given this list of classes that you must take, and you must take in a certain order, and there's no deviation. And there might, at the end of the time, you might have, 1 or 2 classes where you get to choose between this engineering technical elective and this engineering technical elective. But, the one that's interesting me lately is the thought of something like stackable credentials, right? Where you say, okay, you have to take 4 math classes. Here's a list of 10, pick the 4 you want to take. Here's a list of 10 science classes, pick 3 from that list. Here's a list of this, pick this many from that list. And so students would have a lot more free choice. They could customize their degrees. They could study the things that they're interested in, instead of everybody being forced lockstep into, you have to take this, and then this, and then this, and so on. So I think there are some relatively, I don't want to say painless things we could do, but there are some simpler things we could do while we're trying to figure out how to get things like EPICS and the things that we're doing in Olin College pervasive throughout engineering education in the country and perhaps the world.
Yeah, there is an existence proof at Charles Sturt University in Australia, which has, it's not quite stackable modules, but there are courses that students pick and choose among to create their own program.
That's a good segue, actually, I think, into this first reader question or listener audience question that I have here. The question is to President Barabino. Can you say more about how could students participate in the design of curricula? Do they just give ideas, or are they actually like writing down the curriculum? Can you expand on that?
Oh, sure. So Olin, when it started, Olin had what was called partner year, and the students were doing a lot more than just sharing ideas. So like it was, you're working together. We talk about this term called co-creation. So you're at the table, you're with the faculty having the conversations as faculty would have them, like inviting the students in at the very beginning in the conversations. And it's the sharing of the ideas in a way that you're valuing that kind of input. So it's sure you recognize there's a difference between a student and a faculty member, but the student voice is valued in a way that it's seen as an important contribution. So it's sort of like designing together, that kind of collaborative design. And so maybe in ways, a more senior person like a faculty member could be guiding, but is also hearing the voice of the student. So different ways that you can do that. Another good example that's a hallmark of how Olin approaches things is storytelling, actually, like sharing those narratives and building relationships by sharing stories with one another. It's a way to connect. It's a way to value people. And actually, I mean, we lost her just recently, Bell Hooks, but she talked about how you build relationships and communities by sharing those stories. And that's an important piece. And we in technical fields like engineering, it's like stories, what does that have to do with anything? But understanding that, I think that, you know, when you see the power of actually working together on a design, and then you see the outcome of what you work together on, it's the working together actually that does it. And you can do it in so many different ways. And again, just valuing that voice, that input as it's coming in. So we're constantly thinking of ways for the students to take the lead, for students to be in the shared kind of communication, and also like reporting out and then trying to assess how is that working? Like, how do you measure those outcomes? And taking this holistic approach. One last thing I'll say about it is looking at people as individuals and letting them bring their whole selves and their whole identities to the course, to the instruction, to the institution. So that's valued as well, like that holistic approach.
Yeah. My job is all about storytelling. So I like hearing this, right? As journalists, we tell the stories of science and engineering, and we try to translate all that stuff to the public through largely that medium. So that resonates with me. Another question says, how do we get through ABET accreditation using these more modern approaches people are describing? It sounds like there's a lot of discussion about ABET in the chat. So I don't know, Dr. Fortenberry, do you want to lead us off, or if someone else can jump in?
Well, I think ABET is a convenient excuse for a number of people. ABET is us. ABET is a collection of professional societies, which with regard to the academic part is largely made up of college and university faculty. So ABET has some very broad outcome goals that have been set by the societies, the general criteria, and then the specific criteria. And so it really comes down to how are the program evaluation visitors trained? What are they looking for? What biases do they bring? And ABET, I think, does a reasonable job of training its program evaluation visitors. So it really is perhaps preemptive fear on the part of institutions. Very few institutions can credibly say ABET won't let me. And so I think it's a matter of being just a little bit more bold and saying, look, given this outcome, we have decided this is our outcome goal, and this is how we've chosen to meet it, and here's the evidence, which is something that engineers should be able to do.
So, for example, again, I agree 100% with what Dr. Fortenberry just said, that people try to use ABET as the excuse for why we can't change anything. But, in reality, ABET says we need to have 1 year of math and science, which translates to about 32 credits, right? Well, that doesn't mean everybody has to take these, Calc 1, 2, 3, Diffie-Q, linear algebra. I mean, it just says math and science. So we could change the math courses, we could change the science courses, we can do that. ABET only says we only need 1.5 years of engineering courses, which is about 48 credits, right? most programs have 65 or 70 engineering credits. So they're already going above and beyond what ABET is telling us we need in our programs. And so I think, we can bring about change, and we can do it while having accredited programs. It's just going to take a leap of faith, maybe for some people, and a willingness to say, okay, that's how we did it in the past. Maybe we need to change how we do it in the future, right? I mean, we can't let ABET be the driver keeping us where we are. And I don't think ABET wants to be that driver. So I'm not trying to blame ABET for anything.
There's another question here that says, many U.S. engineering universities were founded in the 1800s during the Second Industrial Revolution. As a result, we have an educational factory system. New technical universities have a different structure. We know where we need to go. The question is, how do we get there with the institutions we have? I know we've touched a little on this, and maybe the ABET is speaking to this as well. Is there anything you have to add there? Maybe particularly with these with new technical universities, is that, yeah.
Yeah, so I think, some of the things that we could think about doing is getting rid of departments like they've done at Olin, or somehow breaking down the barriers between departments, because most of the exciting research is done between disciplines. It's not strictly in one discipline or another. And so I think some of the more exciting teaching could be done across what we now call disciplinary boundaries within our programs. And so that's a hard change to make too. I mean, none of these are going to be easy, but like I said, I think there are some things we can think about instead of this rigid structure. We can think about different ways of structuring the curriculum and within what we have right now. But it is a problem.
Well, it's certainly a problem, but I think that's part of why it's so important that we focus on real world problems. So if we think about what are the problems we're trying to solve and how are we trying to solve them, and then how are we educating towards that, and broaden our mindsets and broaden our definitions of or how we can meet certain criteria. So I think part of what Dr. Sorby is saying is not just the criteria, it's how you meet it. And if you see only one way, one narrow way of meeting it, that's constraining. Like I think sometimes in education, we constrain ourselves. Mm-hmm. And so if we free ourselves a bit to broaden definitions, to broaden criteria. Earlier, we talked about the idea of even looking at the structures of reward systems. No one says that some of those things just have to be that way. And Dr. Fortenberry was saying too earlier, like, well, if you just take that and use it as an excuse not to do something. So the broadening of the definitions, the thinking about the real world problems, how we define what it is we're trying to do and seeing more than one path to do that. It's the outcome at the end of the day. And if we just have such narrow views of how to reach those outcomes, or even how we frame and ask questions. So that's another reason why it's important about the diverse perspectives and who we're bringing in and who's asking the questions. Because if it's the same folks who set things up, they're not going to necessarily come up with the new ways of doing things. So bringing in the different perspectives from different populations is certainly going to help move that needle.
This question is from the point of view of a parent of an engineering student. But this parent is asking how they can identify whether a college or university is being more innovative in their engineering education, in selecting maybe a good fit for someone who's interested in a new path.
That I'm not sure about. I guess looking at the kinds of things their students are doing, right? Like what kind of student projects are there? What kind of opportunities for student development are there? Is it just your standard things, or are there extra things? So for example, at my former institution, Michigan Tech, we had a program called the Enterprise Program, where it was similar to joining a consulting firm in your sophomore year, and you kind of grew. You worked on projects throughout the remaining 3 years, and you were able to develop relationships with industry sponsors and all of that stuff. And it was a very team, long-term kind of project. And so that program was very successful in attracting a different kind of student to our programs, right? So I think looking for different engineering programs that to see what things they have besides just the, like the curriculum on paper. What are some of the other opportunities? At my current institution, we have University of Cincinnati, we have required co-op. So all 1,000 students per year are going through co-op and learning, hands-on how to be an engineer in industry. And so I think looking at those kinds of things would help a parent decide, between programs. And, like at Purdue, the EPICS thing, or, I think there's a lot of exciting programs going on right now. My problem with them is that the students going into them are self-selected, right? Only a certain number of students get to go into EPICS. Only a certain number of students go in the enterprise program at Michigan Tech. So how do you bring those experiences for everybody? But until we have this revolution in engineering education, I would say look for some of those kind of programs that are really, they're not always extraneous to the curriculum, but these other opportunities that exist around the country.
Well, yeah, I think you're absolutely right. I think it's not just this opportunity, like, does it appear to be innovative? It's also like, are there opportunities to do something experiential? Is there an opportunity to have any kind of flexibility that's more tailored to you and your interests? Is there an opportunity where you feel like this place gets me? They understand me and can meet my needs, whatever those needs are. And you can see yourself there. I think that's a huge piece of it. And in some ways, that in itself would be innovation, because there's so much attention to making us all fit, so that you start to feel like you have to look and speak and present yourself a certain way to be considered an engineer. So is it a place where you feel like, this is who I am? Can you accept who I am in my package, the way I present? And can I feel comfortable here and be successful? I think that's a big piece of it as well.
Another question here. Going back to the idea that teaching and mentoring is not adequately valued in academia for the professor. So flipping now from the student perspective to the faculty perspective, right? Papers and funding are the metrics that many professors are judged by. How do we do a better job helping mentoring and teaching be more valued in academia?
ASEE has a task force now on faculty teaching excellence, which is really and it's not entirely unique. There are analogs in the United Kingdom and in continental Europe where there are metrics for teaching quality that are national or multinational. So let me step back 3 steps. One of the simple-minded explanations for why we value research, why there's a perception that research is valued over teaching beyond the money that it brings in, is that research there's a generally accepted metric how many papers, and then we can argue about the quality of the papers, but there's a relatively straightforward metric. Teaching is considered highly individualistic, idiosyncratic, unique to the individual, unique to the institution, et cetera. So our effort through this task force is to help to develop some national/international metrics, which would allow for some comparability in counting both within an institution and across institutions. And we believe that that effort over the long term has the possibility to provide, it builds on actually a National Academy of Engineering report that came out 7 years ago. What gets measured is what gets done. As we come up with ways to facilitate the measurement of teaching quality and facilitate means by which both disciplines across institutions and institutions across disciplines can evaluate teaching quality, then we provide a means for teaching to be evaluated on par with research, and therefore we can begin to attain some balance. That's part one. Part two, and I apologize for going on so long, but part two is, I think we need to begin to look at our faculty more as a team, as they do in industry, as they do in government. Right now, there's incredible pressure on faculty to be exemplary across all metrics, teaching, research, and service. But I think if we take a team concept, everybody has to be above threshold, however that local institution defines threshold. But so-and-so has an emphasis on more research. We have research faculty already at many institutions. So-and-so else has an emphasis more on teaching. We have teaching faculty at some institutions. But when I'm talking about the main tenure track faculty explicitly in their contracts, this is my focus, this is what I will be judged on, then I think we can begin to achieve some level of balance.
But I mean, this is, again, it's like the ABET thing. This is us, right? We're, as the senior faculty, we're the ones who are making voting on people getting tenure or not getting tenure. Things, deans are the ones making decisions about whether or not people get tenure. So I think that just like with ABET, we can't let this be the thing that stops us, because this is us. We can make these changes. It's not going to be easy. Trust me, it's not going to be easy. But I think that if enough people start speaking up and saying we need to change this, and we need to change how we're doing this, and we need to change how we're evaluating faculty, we need to change how we're assigning faculty workloads, eventually we'll get there. I don't know how long it'll take. I'll probably be retired by then.
I think we also need to think about learning happening inside and outside of the classroom. Like, it's not limited to a classroom. And so faculty are having to play roles in and out. Faculty are having to serve as mentors and advisors. And we need to show that that's important and valued. It's a valued contribution to the institution, to those we are trying to train for the future, to society. And it doesn't say that every single person is going to be a good mentor or not. But when you have those who are really doing it well, they should be recognized for that. And we should use that as, as exemplars, like, this is what good mentoring looks like. And that's still part of broadening the definitions, like broadening what we mean by teaching, broadening what we mean by research, broadening what we mean by what gets recognized and rewarded. Because oftentimes it's us. Like, we can set these changes in motion. We can set policies and practices. We can do recognition. We can do the reward system. It is us. And I do think there's a combination of what needs to come from the leaders who are responsible and need to be held accountable, as well as those voices coming up. Like, there is something good about student voices being very strong and demanding about, having some voice in their own education. And then for faculty speaking up to the administration, I think you always need this two-way direction where top down, bottom up, all of that together. And those kinds of things will help us address these systemic issues as well.
There's a question here that speaks to the question of retention. If we are, bringing a lot of people, a more diverse group of people in, but failing to retain, is that the right approach? And I don't know if this is actually about students, but it seems like it could be about both students and faculty. So I wonder if what you just described sounds like hard work, and we want professors to stay in their jobs and not burn out, but also students, we want them to see themselves. So I just want to speak a little bit to the question of how we retain the engineering students and faculty of the future that we're hoping to welcome.
Well, I think in the end, we really, part of the reason I think we need to change is for that exact reason, right? Because if we look at the faculty perspective, how many people are we going to be able to attract to be engineering faculty if we tell them, okay, you come here and you work like crazy, 70 hours a week for 6 years. At the end of that, we're going to judge whether or not you are worthy to be a faculty member any longer. And if you're not, then you're gone, right? So that is, I have children who are pursuing PhDs and they're like, I don't want that. I want no part of that. That's not me. But the same with the students. We bring them in, we say, here, go take all this math and science and don't bother us. And then when you're done, maybe we'll let you join us. And so we have this real problem in engineering of being very elitist and making people prove that they are worthy to be among us. And that, I think, is the crux of the problem, or one of them.
So addressing that crux of the problem, because it is, I think it's really critical if we just think about people want to belong. And how do we create environments that feel welcoming and so that people can feel that they belong within that environment? And sometimes we make it so complicated. It is not that complicated to be decent to another human being so that they will feel valued and belong, or like they belong, that they are seen and heard. I mentioned bell hooks earlier, but one of the things that she wrote about was tending to souls. And I recently heard a talk that was given by Christopher Emden. He's at Columbia. And he said that he thought before you do anything, speak to the souls first and then tend to the minds. And I thought that was really profound when you think about just addressing people and making that kind of connection and taking care of the person so that they do feel like they belong, seen, heard, valued. That goes such a long way towards retention. It's not like you necessarily have to have a specific retention program. Like maybe you do it, maybe that's helpful, but maybe a first step is to just create an environment where people can feel comfortable and feel like they belong.
Can the panelists maybe talk a little bit more about interdisciplinary courses? The question is just that simple. So I don't know, maybe, how they're built well, what that looks like in practice.
So I think, again, if we keep coming back to the culture in engineering, and so I think interdisciplinary is where we should be, but I think one of the problems that we have in engineering is, again, our elitist attitude where we think, oh, that person's from humanities. We can't possibly learn anything from that person because we know everything there is to know, right? And so it's really, that's also going to take a significant shift for engineering faculty to be able to work in interdisciplinary teams, because we have this cultural problem where we think we're all that, and so, but I think that that's the kind of thing that is desperately missing in our programs is this, like I said, when I went through, all we worried about was the cost. We didn't worry about any of the environmental impacts or anything like that. But we really, and that's a mistake. We need to work with people outside of engineering, and that's difficult. And part of that also is the reward system, right? Like if you're team teaching something with somebody from the humanities department, who gets credit? How many points do you get for that? Does that mean I have to teach one extra class because I team taught this class? So like all of these things kind of work together. It is systemic change that we need to have going on, I think.
I have a couple of examples that I think work well, just a couple of examples from Olin. It was this idea that you are team-based and it's interdisciplinary. I mentioned we don't have departments, but this idea that you will have teams of faculty working on a real world problem, project-based. And so you may have, in one case, there's an anthropologist working with engineers for engineering for humanity. We may have a material scientist working with a historian, and they're weaving in the history of materials as the students are learning those projects. So a team approach to an area that or a problem that you're working with, but people from different disciplines bringing their lens from the different disciplines to bear on that problem is a great way of working across disciplines, across boundaries, in a team approach where that's more of a dominant model as opposed to the model that's not seen as much, because there are these issues of like who gets credit for what. But if there's this sense of working as a team, I remember when I first started as a brand new faculty member, I actually felt a bit intimidated by, wait, I have all this by myself, and where is that kind of team approach? And if the predominant model is like, no, it's you as an individual, all on you. Yes, you have that autonomy, but also you lose what you could gain from learning from your peers who've actually done something or maybe learned more or sharing those perspectives. So if we have team-based approaches as more of a dominant model, or even just considered a model that is useful and not shunned so much. And maybe we'll move to that more in the future, because what's going to happen is everything we're working on has become more complex. And we are going to have to break down those barriers. The other thing is, if people have noticed, the disciplinary boundaries are blurring. So it's very hard to stay in your silo anyway.
I can remember when we were going up for ABET, we were joking about, because we had to evaluate whether or not our students could work on teams. And we're like, okay, what about the faculty? Like, do we evaluate whether the faculty can work on teams? No, and then we don't want to know the answer to that question.
The time is flying. I can't believe we have only 5 minutes and there's still so many questions, but there is one here, and maybe Dr. Fortenberry, you can answer this first. And it leads from this interdisciplinary course question and sort of project-based learning, which is, how do you make sure that the students still get a corpus of knowledge, right? Like those fundamental pieces of math or whatever, whatever we think that corpus is, so that they can apply it flexibly in these interesting ways that project-based learning leads us to.
So I think even within the context of experiential learning, or maybe to a lesser extent self-paced, there are ways to do that. The trade-off, it's a false trade-off to some degree. If we say we must cover this much material in book X, and it's students are skimming through that information with limited understanding versus a much greater understanding of a smaller quantity of material, where is the real value? The value is in learning something. Now, in my ideal world, which is probably centuries off, we move toward self-paced mastery learning. Now that gets into all kinds of problems with seat time and alignment of courses, et cetera. But what we want are well-trained engineers who know the material, not who sort of skim through. Nobody wants to be on the airplane designed by the C student. So we need to develop ways that give students the space to learn the material. And then once they've learned, to progress to the next step. And I just think that ultimately that's where we need to go, because as Dr. Barabino said earlier on, it's really all about student learning. And so we have to find ways to facilitate, to support, to sustain student learning.
People have done this, right? It's not like it can't be done. There's a university in Sweden, and all they do is problem-based learning for every program for all 4 years, right? So they somehow have figured out how to make sure the students know what they need to know and still have the problem-based learning throughout. So I think, again, people would like to have these excuses for why this can't be done, instead of saying, oh, well, how have other people solved this problem too? And so it's not that this is impossible to do. It might take effort on our part, but it's not impossible.
We're at 2 minutes to the hour. So I think what I'll do is just ask each of you to give sort of a parting thought. Any last thing you'd like our audience to take home? I'll give you about 3. I'll stall here for a second so you can gather your thoughts here. And I don't know, Dr. Sorby, do you want to lead off?
I was hoping you're going to pick me last.
Sorry.
No, that's okay. I think being open to change, open to new ideas, open to rethinking how we educate engineers is really where we need to be. We need to have this mindset shift where we're open to new experiences and new ways of doing things. And I'm not saying that's easy, but I think that that's the biggest thing we all need.
President Barabino?
Yeah, I actually think if we have a simple concept and message, something like engineering for everyone allows us to rethink, reimagine, think about the face of engineering. What do we mean? Like, who's an engineer? What do engineers do? Like, that concept could be a big driving force for us. And
Dr. Fortenberry, the last word.
Yeah, so I think fear is an effective motivator. And ultimately, if we don't find engineering now has to compete for students. And if we don't find a way to compete for a different population than has historically been the population that we attracted, we can't lose them, but we got to find a way to get more people in. And if we don't do that, then the discipline itself is in trouble. So it's about survival. Be creative.
Thank you all so much. I wish I could go back and get re-educated in this model. I can't imagine what path I would be on in that case. Anyway, thanks to all of you. Lisa is back here. I'll turn it over to her.
What an amazing conversation that just really, you've raised so many different issues. I really want to thank you, Jessica, Sheryl, Norman, and Gilda. This was just a fascinating conversation about both the forces for change, the necessity of change, and the complexities of it, and all of the things that can get in the way of change. One of the sort of, it's a funny rallying cry that came up was, this is us, came up all through this conversation of a sort of ownership of a responsibility and a vision as well as all the things that block us. And, as I think, as we look out at the wider things that are going on in our society, in our world, of the ways that we need to change to meet things and the things that block us, this is sort of a microcosm of the complexity here. And also the sense that there's a coming generation that has different expectations and is going to push for some change, but may not have the power to do that at the moment. This is a wonderful conversation, and Issues is just so delighted to be able to host it. This sort of tensions, complexity, multiple visions of the future, and difficult to find resolutions. That is completely an Issues. That's our thing. So if you like this kind of conversation, you've come to the right place. You can read more of our work at Issues in Science and Technology. It's www.issues.org. You can also sign up for a newsletter to hear about other discussions. We will be mailing everybody who RSVP'd for this event a video of a recording of this conversation. I believe it will have the chat on the side. It will not have the Q&A. We will try to think of ways to continue this conversation. This conversation grew out of a piece that Cheryl and Norman and Gary Bertolini wrote for a series that Issues is publishing called The Next 75 Years of Science Policy. And we are also encouraging other authors to come to us, other people with ideas to build upon this idea and give sort of other ideas of how to advance, how to change what science policy looks like and what science looks like over the next 75 years instead of staying with the patterns that we have or saving the good patterns and finding new patterns. For upcoming events, we don't have any scheduled for the new year yet, but please, check our website. And thank you for joining us. Thank you to the panelists. Thank you for Jessica for leading this fantastic conversation. We will see you next time. Have a great rest of your day and hope you can do it in an interdisciplinary way. Thank you.
Thanks.